welcome you all in the 15th lecture of electronics measurement and instrumentation. This is the 5th lecture of CRO. In previous lecture I have discussed the normal CRO, what are the function of the different parts of the CRO, what is the function of the vertical deflection plate, horizontal deflection system, then the delay line system, and then I have also discussed about the different measurements that we can analyzed from the CRO, different front panel controls, and the main part of the CRT that is known as the heart of the CRO, that is CRT. Now, in this lecture I will cover the special purpose CROs. So, special purpose CROs, under this I will cover the dual beam CRO, dual beam oscilloscope, dual trace oscilloscope, sampling oscilloscope, storage oscilloscope. Under storage oscilloscope there are two type of CROs, one is analog storage CRO, another is digital storage CRO. The dual trace oscilloscope or dual beam oscilloscope is not considered as a special purpose CROs, because in general the laboratory CROs are having the dual trace function inbuilt. So, now I will discuss one by one. So, first is dual beam CRO. As we can see in the figure, the dual beam CRO, suppose we want to measure we want to analyze two signals simultaneously. Suppose we have designed an amplifier and we designed it for the gain of 5, then we want to see whether it is producing the gain of 5 or not, and we want to analyze the signal whether the output is exact replica of the input or not. So, we need a CRO that can measure two waveforms. We can use two CRO, but when we are using two CRO they are not synchronized. So, we can't compare both the input and output signal. Similarly, if we want to see the modulating signal and modulated signal simultaneously, then we need a CRO that can at least display two waveforms simultaneously. So, for this purpose the dual beam and dual trace CROs are used. So, in dual beam CROs, at its name suggests, it has two entire section of the CRT, means CRT till the what we can say the vertical deflection and the horizontal deflection, means it has separate cathode, indirectly heated cathode, it has separately, it has two control grade, it has separate pre-accelerating, accelerating and focusing anode, and it also has different vertical deflection plates. So, if we want to measure two signal A and B, two different signal, then entire two sections are allotted for each of the signal. So, as we can see in the figure, if we want to measure a signal A, we will apply this signal at a channel A, and this channel A has pre-amplifier and attenuator as we need. No, then it has separate delay line, separate vertical amplifier, and then it has separate electron gun section, and okay. Electron gun section, it has a separate electron gun section and it also has separate vertical deflection plate. So, this is the dual beam CRO. In dual beam CRO, because of two separate sections are for both the signals, so the signal produced at the screen is very bright. Then second is the dual trace CRO. In dual beam CRO there is only the switching takes place for the horizontal section, the vertical section is separated from each other. In some dual beam CRO the horizontal section is also separated. Since vertical section is separated, so we can individually control each of the input signal. We can vary the time per division of a particular signal, means signal A, signal B. We can vary the volt per division, or we can move individual signal up and down. So, this is the facility of dual beam CRO. The second is dual trace CRO. Generally dual trace CROs are used because they are cheaper than the dual beam CRO and they are not so bulky. So, in dual trace CRO the input A and B are amplified and attenuated, and then it provides the delay time is also provided both the signals separately. Here we can see pre-amplifier attenuated, channel A, channel B, then delay line is there, but after delay line there is a switch, and that switch basically there is an electronic switch, and this electronic switch connects so these are the electronic switch. Basically this switch is suppose here, and it is connected here, and it has this two positions, whether it will connect the channel A or it will connect the channel B. So, when channel A is connected to this vertical deflection plate, when this switch is at channel A and this is connected to vertical deflection plate through vertical amplifier, at this time this trigger circuit is also connected to A channel. So, A channel, when A channel is applied to the vertical deflection plate, then at the same time this trigger circuit, this sweep generator is also triggered with the this input signal. So, this is the connection of the channel A. Then it will alternatively for one complete cycle, it has two mode of operation, one is alternate mode, another is chopped mode. In alternate mode, the one signal is displayed for one complete cycle of the sweep generator. Sweep generator, we know that it produces a sawtooth wave like this way. So, for one complete cycle, one signal is displayed on the screen. For next cycle, the second signal is displayed. But since the signal, the electron beam speed is very high, so our eyes are not able to distinguish between these two signals. We will see, yes, the two signals are displayed on the screen. Then if we want that one signal is applied at the horizontal deflection plate and other signal is applied at the vertical deflection plate, then we will keep it in XY mode, and at that time the XY mode, the horizontal amplifier is connected with the B channel. Okay. So, this is the there is an electronic switch. This switch basically it switches between channel A, channel B, and there is no need of separate electron gun and no need of separate vertical deflection plate. So, this is not a complicated circuit. So, in alternate mode, as we can see for the trace period, this period one waveform is displayed, suppose channel A is displayed, for this waveform the channel B is displayed. Again for the next cycle the channel A is displayed. So, for one trigger cycle, one sawtooth wave cycle, one signal is displayed, and for second sawtooth cycle the second signal is displayed. So, 1 2 1 2, and this way the both the signals are displayed on the screen separately, but we will see it as a continuous signal. The second is the chopped mode. There are two mode of operation, one is alternate mode. For the alternate mode, one signal is one cycle is available for one signal. Then second is the chopped mode. In chopped mode, what will do, a small portion of the signal is displayed on the screen, and but we will see that the signal is continuous. So, suppose A channel, this signal is displayed, for the B channel this type of signal is displayed, and for the trace pair there is for the flyback pair there is no signal. So, again the signal is displayed. So, this is the chopped mode of operation. So, what is difference between dual beam mode, dual beam and dual trace? That in dual beam oscillator two different electron guns are required. In dual trace the same electron gun is useful for both the signals. Now, the second type of oscillator is the second type of CRO is sampling oscilloscope. Sampling oscilloscopes are generally used for the measurement of very high frequency. Suppose we are having a high frequency signal that we are not able to measure by the CRO, then sampling CRO is preferred. So, the function of the sampling, normal CRO has upper limit of 20 to 50 hertz. So, suppose we want to measure the signal of gigahertz. So, what we will do, the higher frequency electron, suppose if we want to measure it directly, then the electron movement is very high, and when electron movement is very high, then the screen, on the screen we will see a very faint trace of the signal. So, for this purpose what the sampling oscilloscope do, it takes sample of the, suppose this is our input waveform and we want to reduce this waveform by 10 times, means we want to reduce the frequency of this signal 10 times by using sampling oscilloscope. So, what sampling oscilloscope does? It does take one sample from each of the cycle. So, suppose it takes one sample here, then next sample here, third here, fourth here, fifth here, sixth here. So, for 10 cycle it takes 10 samples, and from that 10 sample it will produce one waveform, one cycle. So, it means the frequency is reduced by 10. So, here each dot represent the amplitude of the sample of the input signal, and on the screen we will not see the dotted form of the signal, but these signals we will see on the screen as a continuous waveform. Now, high frequency performance can be improved by means of sampling of the input signal. So, advantage of the sampling oscilloscope is it can produce very high speed signal and it can store a rapid bit signal. But what is the disadvantage of this sampling oscilloscope is that it can only measure the continuous signal. If there is a random signal or there is a discontinued signal, then this sampling process is not done on that those signals, and those signals are not to be displayed on the screen. Now, this is the block diagram of the sampling CRO. So, we can see there is a ramp generator and a staircase generator and then voltage comparator. So, here we can see that the staircase or ramps both the staircase generator and the ramp generator both are triggered with this signal. These are the triggering signal. When it triggers the ramp generator will start producing ramp signal. So, this is the ramp signal which is produced by the ramp generator, and when it triggers the staircase generator, then staircase generator produces a staircase signal, step by step increasing signal, and both the signal is produced by from minus V to plus V. Then when both the signals appears at the voltage comparator, so voltage comparator will produce a very small time period signal when both the signals are same. So, when both the signals amplitude is same, the voltage comparator will produce a pulse, small duration pulse. When this duration pulse is fed to the sampling gate, the input signal is fed to the sampling gate. So, what will happen? This when this comparator will produce a pulse, then at that time one sample is taken from the input signal. So, if we want to reduce the frequency by 10, then 10 samples are taken, one sample is taken from one wave, and by taking 10 samples a sine wave is produced. So, this type of sample input is produced and this is fed to the vertical amplifier. When this sampling input is fed to the vertical deflection plate, the same time the unblanking circuit is also switched on, and it will switch on the cathode, so that cathode generates an electron beam for this particular voltage. So, this is the sampling CRO. Now, we will discuss the analog storage CRO. So, in analog storage CRO, two types of CROs are used. One is mesh storage and other is phosphor storage. Although these CROs are not useful for in today's scenario, because we are using now digital storage CROs, but we are using it in laboratory after before some years. So, this is the mesh storage oscilloscope. So, mesh storage oscilloscope has all the facilities that a normal CRO have. Only the difference is that apart from that, means it has vertical deflection plate, horizontal deflection plate, it has phosphor screen, but apart from the CRT, normal CRT, it has flood gun, it is has some extra part, that is the flood gun, collimator electrode, collector mesh and storage mesh. So, collector mesh, flood gun, collimator and storage mesh, these are the 4 parts which a normal CRT is not having. So, what will happen, this is the storage mesh. So, in storage mesh, it is made up of dielectric material. So, when the input signal, when the writing gun is on, then what will happen, this writing gun will produce an electron, and that electron will, since this storage mesh is made up of dielectric material, the electron when strikes on the storage mesh, this due to the dielectric material, it produces a very high secondary electrons. So, when the electron beam strike, the secondary electrons will produce, and that secondary electrons are collected by the collector mesh. And when the secondary electrons emitted from this dielectric material, a positive charge is placed over there. So, suppose we are having an sinusoidal waveform that is stored on the storage mesh. So, this type of sinusoidal positive charges are there, and apart from this there is only the negative charges. So, when this and this collimator electrode, when we want to read, this is stored for a longer time, when we want to read this waveform, and this waveform is also displayed on the phosphor screen, but after some times the phosphor screen does not contain this information is stored on the storage mesh. So, when we want to read this waveform, or we want to see this waveform on the screen, then the flood gun will produce electrons, and what will happen, this flood gun and the direction of electron beam, that it strikes straight to this storage mesh. This is controlled by the collimator. So, collimator basically provide the facility that the electron beam strike directly on the screen by the 90 degree. So, we see that these 3 are the positive charges surface. So, the electron beam will these are the positive charges. So, it will attract the electron because electrons are the negatively charged particle, but here these are the negative charged particles. So, this will reflect the electrons. So, the reflected electrons are collected by the collector mesh, but the electrons that will pass the storage surface, that will be impinging on the phosphor surface, and it will be displayed on the CRT screen. Then next is digital storage CRO. Analog storage CROs are not used today because they are very costly, and the configuration of that CRO is also very complicated. So, nowadays the digital storage CROs are used because in digital storage CROs we can store the data for a very long period of time, and it can be displayed whenever we require. So, digital storage CRO, the basic difference with normal CRO, that it has a memory device, and for to store the data in the memory we need an analog to digital converter. So, if we see the circuit of the digital storage CRO, analog input is applied, then it is attenuated or it is amplified by the vertical amplifier, whatever the requirement that we will use the circuit. So, if it is attenuated, if the amplitude is high, if amplitude is low, it will be amplified by the vertical amplifier. Then there is an acquisition system, then it is fed to, it has to be stored in the memory, so that whenever we need we can retrieve that data from the memory. So, analog to digital conversion is required, because the memory will store only the 0 in the form of 0101. So, for this conversion we know that there is a requirement of sampling, then hold circuit, sample and hold circuit, then there is a requirement of quantization circuit, then after quantization we need to decode the signal convert the signal from the discrete form to the digital form, and then it is stored in the memory. So, when the write operation is done, this is the part of the write operation, the signal is stored in the memory. And if we see that the signal is also from here, for the triggering purpose, the signal is, one part of the signal is fed to the triggering circuit. So, this is the writing part, the signal is stored in the memory. Now, we want to display the signal on the screen. The main digital storage CRO, we can also connect these digital storage CRO with our computer system, and we can also find the display on that. But if we want to display the signal on the digital storage CRO, then the read operation is performed. At that time the input signal is the signal that is stored in the memory, that is converted into analog form, and then signal processing, it is amplified, modulated, whatever the done, that is the signal processing case, and then it is processed and it is displayed on the screen. So, and this is the diagram of the DSO. So, when signal is stored in the memory, then and when we want to retrieve the signal, because the signal is in the form of 0101 and these are the discrete form, then we have to reconstruct the signal, and for the reconstruction the interpolation is used. So, there are two type of interpolation, one is the linear interpolation, another is the sinusoidal interpolation. In linear interpolation, the dots are displayed because we have stored the data in the form of digit 0101. So, it will produce the dot form, then there is we have to connect the dot to produce the signal. If it is connected in this manner, then it is a linear interpolation and it will not show the actual waveform. So, generally sinusoidal interpolation is done, and in sinusoidal interpolation we will get the exact waveform what the input waveform is there. So, this is the function of CRO. This digital storage CROs are used in three mode: roll mode, store mode, hold mode. So, in roll mode, display the fast fluctuating input signal. If we want to display fast fluctuating input signal, then it is very clearly shown on the screen without triggering. So, it monitors the characteristic of a given input signal to process and display its trace on the screen. In store mode, the signal is stored in the memory. In hold mode or the save mode, the data is saved or held for a while until it gets stored in a digital memory. For a very high frequency, if we want to convert the signal into digital form, then we need a very high converter circuit, analog to digital converter circuit, and these circuits are costly and they will produce some error. So, because of this we are using shift registers before the memory, and the signal is stored in the shift register and then it get converted into digital form. So, this is the save mode or hold mode. Then acquisition mode, sample, peak detector, average mode. In sample mode, the oscilloscope sample the signal and in evenly spaced interval to construct the waveform. This mode accurately represent the signal most of the time. In peak detect mode, it will in the acquisition mode, the signal will show, the oscilloscope will find only the highest and lowest values of the input voltage. In average mode, this CRO acquires several waveforms, average them and then display the resultant waveform on the screen. So, application of the DSO, we know that we can connect it with the equipment, we can analyze the TV signal, we can analyze any video signal, we can analyze 3D signals, we can measure the rise time, fall time or the propagation delay time, we can measure the behavior, we can see the behavior of the capacitor inductance and other things. The advantage, again we can measure the XY plot, can be done on the screen, BH curve we can plot the PV diagram, and it has efficient data display with high quality, and all these we can reconstruct the waveform. We can measure signal the amplitude at any times, we can measure by using by putting the cursor at that point. So, rise time, RMS value, whatever we want to measure, we can measure with the digital storage CRO. So, in this lecture I have discussed the special purpose CRO like digital storage CRO, analog storage CRO, sample oscilloscope that is used for very high frequency measurement. I have also discussed about the dual beam, dual trace CROs. That is all from my side. Thank you all.